All right, in this video, we're going to look at addressing how do we graph just regular logs and natural logs. Okay, when we're graphing logs, we have to remember that our bases are any number greater than 0, right? So it could be a fraction, right? Half, quarter, a third, or it could be an integer, right? 3, 4, 5, things like that. When you have a natural log, the base is always e. And we have to remember that e is roughly about 2.718, and that's as far as we need to go, okay? Keep in mind this is ln natural log. A few people I have known have written it like it's in, as if it was in. Again, that's incorrect, right? It is an L. Okay, so for our class, what I want you to focus on is that for regular logs, I want at least 2 points, right? If you can give me more, perfect, but at least 2 points. And then for a natural log is just at least 1 point. Okay, the second and third and fourth point for natural logs become harder and harder because the base is an irrational number, e. Okay, so before we begin, we have to remember what our generic equation is for natural logs and regular logs. So I'm just going to write it for logs. So this would have some sort of base, and then you would have an h and k. So remember your h is your horizontal shift, your k is your vertical shift. In our case, our h actually is our vertical asymptote. So VA stands for your vertical asymptote. So when x is equal to h, that's your vertical asymptote. Essentially, if you plug in an h into this equation right here, you're going to end up with 0. So that's essentially what you're doing, is you're setting this guy equal to 0 and you're solving. Okay. Now, I have what's known as a locator point. Locator point. I think I spelled this wrong. Locator, right? Locator point. And this will help you with at least the 1 point, and it'll get you started for the second point. So how you're going to do this is you're always going to start at 1, and you're going to add your h value. And then for the y, it'll be a 0, and then plus whatever your k value is. Again, I'll show you how we can derive this if we just kind of make a table of points if we're creating a graph. Okay, so let's take a look at our very first example, right? So number 1, this is going to say f of x is equal to log base 2 of x minus 3. All right, so here's our first problem. All right, so the first thing I want to do is I want to tackle my vertical asymptote. So my VA. So essentially I'm going to set my x minus 3 equal to 0. And if I do that, I'm going to get x is equal to the number 3. So that means that this is undefined at the number 3. So if I plugged it in and I said log base 2 of 3 minus 3, this would give me log base 2 of 0, right? There is no number that I can raise to the power, I can raise 2 to the power of to get 0. So this is undefined, does not exist. Okay, and so we represent that on our graph kind of as a dashed line. And then we have to decide, are we going to be graphing on the right side, 4, 5, 6, or are we going to be graphing on the left side, right, 2, 1, 0, and so forth, right? So this is where the locator point can come in handy. Right, so locator point. So I'm going to take the 1, it's always a 1, and I'm going to add my h value. I already know what my h value is, it's 3. And then I'm going to take my 0 and add my k value. Well, there's nothing added to the end of my log problem, so that becomes 0. So that means my locator point happens to be 4, 0. So now I know I'm on the right side of that vertical asymptote. And you can double check that this point is true. If you plugged it in, log base 2 of 4 minus 3, this becomes log base 2 of 1. And again, you're asking yourself, what do you have to raise 2 to the power of to get to 1? And that number is 0. Okay, ideally, if you can kind of remember your exponents, so we know that 2 to the power of 1 gives you 1, sorry, 2 to the power of 2 gives you 2, 2 to the power of 0 gives you 1 is what I meant to say, 2 squared gives you 4, 2 to the power of 3 gives you 8. This will help us understand what you have to necessarily plug in for x. You want this whole set of parentheses to equal these numbers. So you're trying to figure out what else do you have to plug in. This will help you find your second point. Okay, and at this point, it's kind of a guess and check, right? How you set up your little table of points. So I plugged in, so I see that I plugged in a 4. I could try plugging in a 5. So 5 minus 3 gives me 2. Perfect, that works. So I'll go ahead and say log base 2 of 5 minus 3. So this gives me log base 2 of 2. Again, what do you have to raise 2 to the power of to get to 2? I know that that's 1. So my second point should be 5, 1. So I now know that I'm going in this direction. Like I said, 2 points are great, 3 or 4 points are even better. So if I want to pick my third point, right, logic says I should probably pick, say, 6. So log base 2 of 6 minus 3. Well, notice what happens. This is going to give me log base 2 of 3. I have no idea what I have to raise 2 to the power of to get exactly 3. I can't figure that off the top of my head, nor do I want to. So I probably would not choose this point. I'd probably want to pick a different number. So I'm pretty much looking to see what's going to give me 4. So I know that if I plug in, say, a 7, that's going to give me log base 2 of 4, and that does work, right? 2 to the power of what gives you 4? I know that it's 2. So my number should be 7, 2. Again, notice that my graph doesn't go that far. Let's just pretend that it does, and this is 7, and then this would be 2. So again, I have a nice little curve to my graph, and then I can connect my points. And then I'm done. We did talk about domain and range. Your domain is all your numbers that you could plug in. So technically it always starts at your asymptote. And depending on if you're on the right side or left side, right, it'll either be going to infinity or starting at negative infinity. And then your range, no matter what, will always be negative infinity to positive infinity. Okay? And that's our first one. So let's try a second one. And if you want to try this one on your own, by all means, pause the video and see kind of how much you get correct on this. So log base 5 of x plus 2 and then minus 1. So again, like I said, if you want to try this on your own, pause the video and then unpause it and see how you do. Okay, so if we're checking our answer or following along, the first thing I'm going to do is find my vertical asymptote. So again, I'm setting my x plus 2 equal to 0, and I'm going to get x is equal to negative 2. Remember, your vertical asymptote is a line, and you should be writing it as such, right? You shouldn't just tell me that it's negative 2. Okay, it is negative. Again, if you plugged it in, this would give you log base 5 of negative 2 plus 2, and again, this does not exist. You can't raise 5 to the power of something to give you 0. So D and E. All right, let's go to our locator point, so LP. So this will become 1 plus negative 2, and then 0 plus negative 1. So essentially, this will just be negative 1, negative 1. So again, if we can plug it in, wonderful. So now what I'm trying to do is I know that 5 to the power of 0 gives me 1. 5 to the power of 1 gives me 5. 5 squared gives me 25. So I'm trying to figure out what numbers I can plug in to get 1, to get 5, to get 25. Well, the good news is I've already figured out how to get 1. If I plug in negative 1 plus 2 gives me 1. So I've already figured that out. So what do you have to plug in to get it to be a 5? Well, what plus 2 gives you 5? And that answer is 3. So 3 plus 2 gives you 5. So log base 5 of 5 minus 1. So this little guy right here, 5 to the power of what gives you 5? This is 1, and 1 minus 1 gives you 0. So our second point should be 3, 0, which is all the way out here. So this would be a good one where 2 points are really good. You're not going to be able to graph your third, you wouldn't be able to graph a third point. So the next number you'd try to have to get is 25, and that would have to be log base 5 of 23 plus 2, which gives you log base 5 of 25. 5 to the power what gives you 25? 2, which gives you 1. So you'd be plotting 23, 1. That's way out here. So we know that it's slow to grow, but it is growing. So we can go ahead and we can connect the points together. Okay, and that's it. Our domain should be -2 with an infinity sign, and our range is -infinity to infinity. Again, remember that there are parentheses around the -2 because the -2 is not included. Okay. Now, both of number 1 and number 2 are what's known as a growth graph. The graphs keep going up and up and up and up and up, right? What would something like a decay for a log look like? So let's look at example number 3. So f of x is equal to log base 1/4 and x minus 1. And again, if you want to try this and see how far you get, by all means, pause the video. All right, so what makes this different is that your base is actually smaller than the number 1. But we can still do everything that we've been doing on our previous problems. I can still find my vertical asymptote. My vertical asymptote is at 1 because what is 1 minus 1? It gives me 0. I can't raise 1/4 to any number to give me 0. So I know I'm at my undefined point. Okay, I can still find my locator point. So this will become 1 plus 1, and then 0 plus 0. So this just becomes 2, 0. 2, 0. Bam. So now for the next numbers, all right? This is what makes it a little bit tricky. So I want you to realize that the base is a fraction. So there's a couple different ways that I can write this. So I know that 1/4, all of this is being raised to the power of 1. If you remember your exponent rules, when you want to turn a fraction upside down, right, to make it 4 over 1 or just 4, then we make the exponent the opposite, right, negative. I could also look at 1/4 as the same thing as saying 1/2 squared. And then this now becomes, instead of 1/2, rewrite that, this can become 2 to the power of -2. So again, 2 different ways that I can write this. Both of these are going to help me potentially find my next point. So, so let's take a look if I plugged in. So what happens if I plug in, say, a 3? So I say 3 minus 1. So this would become log base 1/4 of 2. So again, I'm asking myself, 1/4 to the power of what number is going to give me 2? Well, I want them to be the same base, so I know I'm going to replace the 1/4 with 2 to the power of -2. And then I'm going to add that y in, because when you multiply power by, or when you raise a power to a power, we multiply. And then this 2 also technically has a power of 1. And we learned either in integrated 1 or math 9 that when you have the same base, you can set your exponents equal to each other and solve for y. So we have a point called 3 (1/2). And that point is probably somewhere right about there. Okay, can I plug in a different number? So let's see what else. So could I plug in, say, 4? So 4 minus 1, that's going to give me 3. There's no way to make a 4 become a base of 3, so I'm going to skip that one. So let's try 5. So 5 minus 1, that is going to give me a 4, and that's going to work. So 1/4 to the power of something is going to give me 4. So now I'm going to use the top one. So it'd be like saying 4 to the power of -1, and again, raise that to the y. Write the exponent of 4 as 4 to the power of 1. So again, I can set my exponents equal to each other and get -1. So I get 5, -1. So again, notice what's happening with your graph. This time, it's going down. So it is a decay graph. So this time it starts on a high end of your asymptote and then comes through your points. Kind of like a slide, a never-ending slide, so to speak. And again, our domain is still the same. It doesn't change. We're going to still start at 1 and go to infinity. And we can still get any number out from negative infinity to positive infinity. The positive infinity is going to be a number that's smaller than the number 2. All right, last but not least, let's try natural log. So remember, natural log has a base of e, which is roughly about 2.718. Okay, so what happens if I give you this fourth example? So f of x is equal to the natural log of x plus 4. Notice that I don't have parentheses, okay, around this. So it's like saying natural log of x and then plus 4. The plus 4 is on the outside, so these are exactly the same. All right, so this means that my vertical asymptote is actually going to be at 0 this time. This one's going to be a little bit harder, so I'm going to use a highlighter to show my asymptote. And my LP, locator point, so 1 plus 0, and then 0 plus 4. So this is just going to become 1, 4. So like I said, you're really only going to make 1 point. We know that it's 2.718, so 2.7 is a little bit more than the number 2, so it should kind of mimic our first graph. So it should be kind of going up and up and up and up and up. It's not going to be going down. And so we'll have something that kind of looks like this. Okay, now if we really wanted to find a second point on this, okay, the easiest number to plug in is the letter E. So if I wanted to do a second point, I would say the natural log of E plus 4. Well, what is the natural log of E? Well, E to the power of what gives you E? This is 1. And 1 plus 4 gives you 5. So technically, you'd be plotting E, comma 5, which is about 2.718. So if I go to 2.7, so here's 2, and then I should have gone up a little bit more. So let me redraw my graph. Doesn't feeling like it. So 2.7, something right about there. It should be an output of 5. So this is what our graph should look like. A little bit better. Again, like I said, for natural logs, you really only just need 1 point. If you want to try a second point, if the problem's not too hard, by all means, go for it. But really for natural logs, I'm just looking to make sure you have the right direction and the right locator point. All right, let me know if you have any questions.